Hi all, today's topic is permutation. So what do you mean by permutation? A permutation is a bijective mapping of a set onto itself is called permutation. So we have only three elements, then we have six permutations are possible. For example, if it is three element, 1, 2, 3, 1, 2, 3. So what are all the possibility for writing three elements? We have to write it 1, 2, 3. 1, 2, 3, 1, 2, 3. So down, what are all the possibility? It can be a same element, 1, 3, 2, any option. You can change and write, it is not wrong. 3, 2, 3, 1, and 2, 1, 3, and 3, 1, 2, and 3, 2, 1. Yes, all the possibility I have written, all the possibility all the six. So it is denoted by the symbol S3. Only three element means S3. Four element means S4. Etc. It goes on. It is Sn. N is number of the elements. How many elements you have. We know that S3 is a group under operation star. So how it is a group, first I will tell. Okay. So before going with the group, so F star G is nothing but star operation. When we do a permutation, how we have to do it means it is nothing but G composition F. Okay, G dot or dot product, we'll say it's a composition. G composition F is nothing but it's a composition. So F and G belongs to an S3. So first I will prove how it's coming. First I will prove. So when we take any two element P2 into P, instead of F and G, I'm using the permutation. So P2 star P3, when I do it, left first I will do, it's nothing but P3 composition P2. So before going with this, it's nothing but P2 into P3, we have to do it. When I do it 1, 2, 3. So P2 to P3, we have to multiply it. So this both. Okay. So this both, it is nothing but P2 element. It's 1, 2, 3. 1, 3, 2. P3 elements 1, 2, 3. 2, 3, 1. Okay. So now when I do it, 1 is mapped to 1. Again, 1 is mapped to 2. Okay. So answer is 2 for a 1. Now 2 is mapped to 3. 3 where it is mapped, 3 is mapped to 1. So 1 is the answer for next. Okay. Same way 3 is mapped to 2. 2 is mapped to 3. So 3 is the answer. So this element, it belongs to which we have to cross check it. You check it is a P4 element. P4. It will be repeated only when you do a composition. Okay, so when you do a star operation, it will be any of the element only. When you do any other two element, when you take a operation star operation, when you do it, you will get the same element only you will be getting. So the table for this permutation. So this general, so same way every element you have to do it. When you write this table only, it will be easy to check whether it is a group. It will be directly easy. For that case only I am writing this table. It is P1, P2, P3, P4, P5, P6. Same way in this P1, P2, P3, P4, P5, and P6. 6. Now, each element when you multiply it, so P1 into P1 you multiply and check it, you will be getting the P1, P2, P3, P4, P5, P6. So the whole table I will write it like this: P2, P3, P4, sorry, 1 minute, P2, P1 here, P1, P4, P3, P6, and P5. Next will be P3, P6. The same arrangement you will not have. When you multiply only, we know what answer you are getting. You have to multiply and check it. Why we are writing this table means it is easy to prove whether it is a group. Okay, already I told S3 is a group I told. So it is easy for checking only. I have written this table. Completed. Completed. The table has been completed. Now we will check whether it is a group. Group means what are all condition I have to prove. Group, it is a closure property I have to verify. Associative I have to verify. Inverse and identity I have to prove. And abelian also, whether you are going to check whether it is a abelian or not also, we are going to check it. So now closure property. From the table, closure property, you take every element. So star operation, it is a closure property. Closure, first closure property. So closure property, it's nothing but star operation is closed only. All the cases we got the answer. So it is in S3. Okay, because you are not getting means that time only this closure property is not satisfied. Every element, see, you take one row. So 1, 2, 3, 4, 5, 6, all the element is available. So it is a closure property satisfied. So same way associative. Second is associative. You check any two element only, you take it and check it. Randomly we will check it. So when we take a permutation, it's nothing but P2 into P3 into P4. It's nothing but open bracket P2 into P3 star operation P4. So when we multiply it, okay, now you check. So P3 into P4, what is answer? P3 into P4 is nothing but P2. Okay. Same way P2 into P3. P2 into P3 is nothing but P4. So both element you multiply and check it. So it will be equal only you will get. P2 into P2. P2 into P2 is nothing but P1. Same way P4 into P4 you check. It is same P1 element. So it is associative is satisfied. Okay, third is identity condition. So identity, we are going to check which is the identity. For that, I don't know which is the identity. So general first I will check it. So I will take identity element. First I will take P1 only identity. I will guess and I will check it. P1 is identity element. How we will check and find out. For every element it should be identity. Then only I can write P1 is the identity element. For example, suppose P2 star P1 equal to P1 star P2. Same P1 if I get, it is the identity element. Okay, so now you check it. P2 into P1 is nothing but P2. P2 into P1. P2 into P1 is nothing but P2. Same way P1 into P2 is nothing but same P2. Okay, we are getting same element. Same way P3 star P1 equal to P1 star P3. You check. When I check it, P3 into P1 star is nothing but P3. Same way P1 into P3 is nothing but same P3. So same element only I am getting. So what is the meaning? So any element I multiply with P1, I am getting P1 only. So P1 is the identity element. Okay. P1 is the identity element. So it's satisfied for all the cases. P1 is the identity element. So now inverse. What is the inverse? Fourth condition is inverse. When we prove for an inverse, inverse, I don't know which is the inverse. So P1 inverse is the P1 element. Same way, P2 inverse is the P2 and P3 inverse is a P3, etc. It goes on. So now I will multiply and check whether, so A star, A inverse is nothing but identity element. It's already we know that it is P1. Okay. So now when I multiply P1 star, P1 inverse, so when I multiply it, okay, P1 star, P1 inverse, when I multiply it, what I'm getting, I have to check. Okay, so it's nothing but, so same P1, same way, P2 star, P2 inverse, I will show you. So P2, what is our P2 element? So P2 element we have taken to be 1, 2, 3, 1, 3, 2. So P2 inverse is nothing but, okay, 2 is mapped to 3, 2 is mapped to 3, 3 is mapped to 2, 1 is mapped to 1. So this is the element. How we have to write the inverse? From a down to top. Okay. So P2 inverse is nothing but 2 is mapped to 3, like that we have to write it. Okay. So it is nothing but same element only I have. When I take a composition, 1 is mapped to 1, 1 is mapped to 1. So I will be getting the same element only I will be getting. So it's nothing but the same element is nothing but what we will be getting. So 1 is mapped to 1 and 2 is mapped to 3. So 3 is mapped to 2. So 1, 2, 3 only I am getting. Answer I am getting 1, 2, 3, which is nothing but P1. So every element, it's the same thing you can check. P3 into P3 inverse also you check. So same element only you will get. 1, 2, 3 only you will get. Same P1 only you will be getting. So every element, the corresponding element is the inverse. Okay, Pi. Therefore, Pi inverse is the inverse of each element Pi. So therefore, S3 is a group. We have proved it is a group. So now we will go with the problem so that we can understand permutation. You can understand clearly. First question. So first problem. If alpha, beta are the elements of a symmetric group S4, given alpha equal to 1, 2, 3, 4, 3, 4, 2, 1, beta equal to 1, 2, 3, 4, 2, 4, 3, 1. Find alpha beta, beta alpha, alpha squared, and alpha inverse, and also find the order of each element. Also find the order of alpha, beta, and alpha beta. So this only we have to do it. So how we have to do the permutation? So first case, two given elements alpha and beta are given. First alpha beta I have to do. So alpha into beta I have to multiply. So alpha star beta. So they did not give anything. So alpha star only. So when I multiply it, 1, 2, 3, 4, 1, 2, 3, 4, 3, 4, 2, 1, 2, 4, 3, 1. So what is the answer? 1, 2, 3, 4. So when I now multiply it, 1 is mapped to 3, 3 is mapped to 3. So for this answer 3. So 2 is mapped to 4, 4 is mapped to 1. So 3 is mapped to 2, 2 is mapped to 4. Same way 4 is mapped to 1, 1 is mapped to 2. So completed. So this is the way alpha beta. Same way beta star alpha. So write first beta then alpha. Beta 1, 2, 3, 4, 2, 4, 3, 1, 1, 2, 3, 4, 3, 4, 2, 1. Okay, completed. So now when I find the answer, same way 1 is mapped to 2, 2 is mapped to 4. So 2 is mapped to 1, 2 is mapped to 4, 4 is mapped to 1. Same way 3 is mapped to 3. So 3 is mapped to 2. So 4 is mapped to 1, 1 is mapped to 3. So completed. Beta alpha. Then alpha squared. Alpha squared is nothing but alpha star alpha. Same both are alpha. 1, 2, 3, 4. 1, 2, 3, 4. So it is 3, 4, 2, 1. 3, 4, 2, 1. Same procedure only. 1, 2, 3, 4. So 1 is mapped to 3. 3 is mapped to 2. 2 is mapped to 4. 4 is mapped to 1. 3 is mapped to 2. 2 is mapped to 4. 4 is mapped to 1. 1 is mapped to 3. So completed. Same way alpha inverse is nothing but when you write it 1, 2, 3, 4. How we have to write it means, so alpha, this is our alpha. 1 is 1, 2, 3. Now how we have to check it? Reverse. Yeah, from a down to up. 1 is mapped to 4. 1 which is mapped you have to check. From a down you have to check. So 1 is mapped to 4. So that is the answer. Next 2 I have to check. 2 is mapped to 3. 3 is the answer. Next 3 you have to check. So 3 when I check it. So 3 is mapped to 1. Okay. So now 4. 4 is mapped to 2. So this is the alpha inverse. Okay. Next alpha squared already completed alpha inverse. So before going with everything I have calculated alpha squared done and alpha inverse all the 4 we have calculated. Find the order. How to find the order means we have to find order. Order how to find it means, so any powers you have to calculate first. Which power you have the same element, that will be the order. For example, alpha. For alpha first I need to calculate. For alpha order I am going to calculate it. First alpha squared. So alpha squared already in the question. Alpha squared in the question. This is called alpha squared. So already we have calculated in the third subdivision. So we did not get the same element. 1, 2, 3, 4. You have to get the same element. So I will go with alpha cube. It's nothing but alpha squared star alpha. Already alpha squared answer I have it. That I have to write it 2143 into alpha 1, 2, 3, 4. So 3, 4, 2, 1. So now when I write it, alpha cube. So alpha cube 1, 2, 3, 4. So when I write it, 1 is mapped to 2, 2 is mapped to 4, 2 is mapped to 1, 1 is mapped to 3. So 3 is mapped to 4, 4 is mapped to 1, 4 is mapped to 3, 3 is mapped to 2. So I'm not getting the same element. Go with alpha 4. So alpha cube star alpha. Alpha cube now only calculated. It goes on till you get 1, 2, 3, 4. Same answer you get it. Till that we have to do it. So that will be the order. So in this 1, 2, 3, 4. So 4, 3, 1, 2. So alpha is nothing but so 3, 4, 2, 1. So now we'll check 1 to 4. 4 is 1. 2 to 3. 3 to 2. 3 to 1. 1 to 3. 4 to 2, 2 to 4. So now you check both answers are same. So the order will be 4. Order of alpha is 4. So completed. This is the way you have to do. Order of alpha is 4. So completed. Same way order of beta. So beta, when I calculate beta squared, I will calculate beta cube. Beta squared when I calculate. So 1, 2, 3, 4. So it's nothing but 4, 1, 3, 2. Beta cube answer. So 1, 2, 3. Yes, beta cube. I'm getting the answer. So the order of beta is 3. So it is nothing but order of beta is 3. Same way alpha beta order. Alpha beta both you multiply it with respect to 3 and alpha beta power 4. Okay, when I multiply it, okay. So already 1, 2, 3, 4. Already alpha beta the whole square we have done. That answer I am taking into one more time. So 1, 2, 3. So when I multiply it, 1, 2, 3, 4, 4, 3, 2, 1. So again one more time 1, 2, 3, 4. The corresponding answer 3, 2, 1 into again one time alpha beta 1, 2, 3, 4. So 3, 1, 4, 2. So I am getting answer 1, 2, 3, 4. Yes, 1, 2, 3, 4. Same answer I am getting. So the order of alpha beta is 4. Order of alpha beta is 4. So we have completed. Thank you.